Again, you are most welcome to today's math class. Question before us here is m minus 3, or in brackets, all raised to power 4 equals to 7 to the power of 4. Here we are asked to find only the real root to this challenge. So how do we go about this? Without much waste of time, let's take calculation. With these expressions here, let's move this quantity to this side of the equation, which is the left-hand side. So this gives us here bracket our m, then minus 3 close bracket to the power of 4, then minus our 7 to the power of 4 equal to 0. We want to rewrite this exponent to enable us to evoke the difference of 2 squares. Okay, so here we're going to write this as our bracket in our m minus 3 close bracket to the power of 2, or in a square bracket to the power of 2 and minus 7 to the power of 2, or in bracket to the power of 2 again equal to 0. What does the difference of 2 squares say? It says that if you have your x to the power of 2 minus y to the power of 2, this is equal to bracket or x minus y plus bracket x plus y. Okay, so if this is all called the difference of 2 square, as we all know, we can rewrite this in this format. But this is raised to power 2. So the whole of the quantity inside here is our x. And the whole of this quantity, which is 7 to the power of 2, is our y here. So let's write this expression. So this is going to give us our bracket m minus 3 all to the power of 2 into our square bracket to the power of 2 minus bracket 7 to the power of 2 into power of 2. This is equal to, let's take time to write it. So we have here bracket, what is our x? Look at our x. The whole of this is our x, right? The whole of this expression is our x. So this is going to give us our m minus 3 all to the power of 2. Okay, then minus, what is our y here? The whole of this is our y. Minus 7 to the power of 2. Then we put this in a square bracket, then into another square bracket, which is going to give us bracket our m, then minus 3 all to the power of 2 plus our 7 to the power of 2. And we also put this in a square bracket equal to 0. Okay, so from here, we now have the whole of our expression to be our bracket square open bracket our m minus 3 all to the power of 2 plus our 7 to the power of 2 plus bracket open square bracket our m minus 3 all squared, then plus our 7, sorry, minus our 7, right? Or yes, minus, please. Yes, minus, sorry, yes, minus, then plus our 7 all to the power of 2 plus bracket equal to 0. So here we can apply the zero product rule, where we equate this to 0, equate this to 0. So we're going to have our case 1. So in our case 1, we have our bracket, our m minus 3 plus bracket squared minus 7 squared is equal to 0. So let's solve case 1 first. If this will give us real solution or imaginary solution. So if it's going to give us an imaginary solution, we're going to ignore it. So we have to open up this. So opening up this will give us here bracket m minus 3 plus bracket m minus 3 plus bracket minus 49. This is equal to 0. So m times m will give us m to the power of 2. Then m times minus 3 will give us minus 3m. Then minus 3 times m will give us minus 3m. Then plus minus 3 times minus 3 will give us plus 9. Then minus 49 equal to, we just have to add these two together to give us our m to the power of 2 minus 6m minus 40 equals to 0. So among the factors of 40, we think of two factors or two numbers that when we add together will give us minus 6. Then multiply together will give us minus 40, and that will give us plus 4 and minus 10. So if we do that, we just have to rewrite this expression we have here, and that is what I've done here. Put this in bracket, put this in bracket, and factor out terms that are common to each of these brackets. So for here, m is just common to this. Hence, I brought out m. So here I'm left with m plus 4. Here we have 10 common. So we have here minus 10. Then if you use this minus to times this minus is going to give us plus. So you discover what we have here and what we have here are the same. So we take only one and take these that are outside. So we have here our m minus 10 are outside. The bracket our m plus 4 inside is equal to 0. So we have two cases here. So we take this first one. So we have our m minus 10 equal to 0, or our m plus 4 equal to 0. Okay, so if we send this to this side, we now have a m1 is equal to 10 and our m2 equal to minus 4. So let's keep these two answers, and these are real solution. Let's take our case 2. If case 2 will give us real solution, because we have to look for 4 roots to this challenge, but here we are restricted to only the real solution. So our case 2, let's take our case 2. So where's the question now? Look at our case 2 here. Our case 2 is taking a plus sign. So we can now rewrite this as our bracket open our m, then minus our 3 to the power of 2, then plus 7 to the power of 2. This is equal to 0. So from here, we open up this again. So if we open this, we're going to come up with our m squared minus 6m, then plus our 9, plus 49 equal to 0. Okay, so let's continue here. So we can now go ahead to add these two together here. So 9 plus 49, that will give us 58. So we now have here our m here to the power of 2, the minus 6m, the plus our 58 equal to 0. Now, do not forget that we are asked to look for only the real root. So we have to check if this will give us real solution. Because here we cannot use factorization method to simplify this. So let's use our data equal to have b squared minus our 4ac. So from here, what is our b? Our b is minus 6. So I have here minus 6 all to the power of 2 minus 4 into our a is coefficient of m squared, which is our 1 here, bracket, the bracket. What is our c? Our c is constant term, which is 58, close bracket. So this will now give us 36 minus 4 times 1 times 58. That will give us 232. Okay, so from here this is going to give us negative. So we have here minus 196, right? 196. Oh, so look at our data here. So since we have this to be negative, definitely we are going to have imaginary roots from this part, and we don't need that. So we are asked to look for only the real roots. So we have m1 is equals to 10, m2 is equals to minus 4. But we can do a simple check to this. To answer here, if they will satisfy the original equation. So let's take our check. So we're taking our equation, which is m minus our 3 all to the power of 4 equal to 7 to the power of 4. So the first thing here is to put in the first root, which is m1, 10. So when our m is equals to 10, then now putting here 10 minus our 3 all to the power of 4 equals to 7 to the power of 4. This will now give us 7 to the power of 4 is equal to 7 to the power of 4. So this shows that the first root m1 equal to 10 satisfies the original equation. So when our m2 is equal to minus 4, let's substitute and see what this gives us. So here we're going to have our minus 4 minus 3 all to the power of 4 equals to 7 to the power of 4. So this will give us minus 7 to the power of 4 in bracket is equal to 7 to the power of 4. What is minus 7 to the power of 4? It's same thing as minus 1 to the power of 4 times 7 to the power of 4. So minus 1 to the power of 4 will give us positive 1. So this automatically gives us 7 to the power of 4 equal to 7 to the power of 4. Okay, so this means that the second root also satisfies the original equation. So this satisfies the original equation and this satisfies the original equation. So this brings us to the end of this math class. If you learned something from this video tutorial, do not hesitate to give the video a thumbs up. And if you are not clear any of the steps applying, explaining, or solving this math challenge, then leave a question in the comment section. We are there to reply to your comment. Thanks for watching Math Progress. Bye now.